All right, let's dive into Java. We've got all your sources here about Java programming, and we're going to break them down today. Even if you're not a programmer, understanding software is like surprisingly relevant these days.
Right. Java is kind of the backbone of so much tech we use every day.
Exactly. We'll uncover that write once, run anywhere, magic. And guess what? We'll even explore how to, well, give instructions to a Java
And
program.
that's all thanks to the Java Virtual Machine, or JVM for short.
JVM.
Okay,
Okay.
it's like you could imagine it as a universal translator for computers.
Yeah.
So that same Java code can run on, you know, different systems like Windows,
Whoa. Well,
Mac, even Linux.
so one piece of code works on all those. How is that possible?
Think about if every app you downloaded had to be like specifically designed for your phone model.
Yeah, right.
So the JVM solves this, acts as a middleman.
Hmm.
It takes the Java code, translates it into instructions for each operating system.
Oh, so it's like taking a recipe and adapting it for different kitchens?
Yeah, that's a good way to think about it. That's the beauty of the JVM. This write once, run anywhere.
Hmm.
We call that WRA sometimes.
Yeah.
You write the code once, and thanks to the JVM, it runs on tons of devices and platforms.
Oh, wow. That's efficient. So JVM makes Java super adaptable. What else does it do, though? My notes mention memory management and security.
Yeah, does.
Uh,
It's a multitasker. So it doesn't just translate code, it manages the computer's memory for the Java program.
okay, so it keeps it from crashing.
Exactly, yeah, making sure it
Yeah.
doesn't use up all the resources and crash everything. And yeah, it also acts as like a security guard, prevents any shady code from causing trouble.
Okay, so the JVM is like the unsung hero behind the scenes, make sure everything runs smoothly, safely. So how does this Java code actually become something a computer can understand?
Okay, so let's visualize this. Picture yourself, you're the programmer, typing up your Java code, you save it in a file, and that ends in .java. That's our starting point.
Got it. Java is like the raw blueprint. What happens next?
Then comes the compiler. This is a tool, it's called javac, and it transforms your .java file into something called bytecode. And this bytecode, it's saved in a new file, and it ends in .class. So it's like converting our blueprint into a set of instructions that are a bit simpler for the JVM to understand.
So Java gets turned into Jot class with this bytecode. It's like translating the blueprint into a simpler language,
Exact.
but not the computer's language yet, right?
Yeah, you're right. The bytecode is like an intermediate language.
Yeah.
Now, this is where our hero, the JVM, comes in. It takes this bytecode, reads the simplified instructions, and then finally translates those into machine code. And that is the language that your computer's hardware actually speaks.
Okay, so Java code, compile it into bytecode, JVM turns that bytecode into something the computer can run.
Right.
But how do we actually interact with this running program? I remember seeing something about a main method and something called args.
Ah, yes. Every Java program has a starting point. Like, think of it as the front door of a house. In Java, that's the main method. It's the first thing the program looks for when it starts running.
The main method sounds important. And it always comes with this line of code that looks pretty intimidating. Public static void main string args. Can we bring that down without getting too technical?
Sure. That line might look scary, but it's just telling the program where to start and how to accept, instructions from you.
Mm-hmm.
Public means this method can be accessed from anywhere.
Yeah.
Static and void, those are a bit more technical. But for now, just think of them as modifiers telling Java how the main method should, behave.
Okay, so those first words set the stage, but what about that string args? What's going on there?
That's where things get interesting. String args is how you, the user, can actually pass information into the program.
Oh,
Args stands for arguments, and it's like a container that holds any extra information you want the program to use.
wait, so I can use args to give it instructions?
Exactly.
That's cool.
Yeah. So imagine a program that can print words in reverse order. You could use args to give it the words that you want reversed. So let's say you run the program and you type hello world after the program name. The program would take those words, store them in args, and then use that information to print world hello.
Okay, that's starting to click. So args is like giving the program specific ingredients to work with.
Yeah.
But how do we actually see what the program is doing with those ingredients?
Right. That's where system.out.println comes in. It's basically a way for the program to talk back to us and show us what it's doing.
Ah, system.out.println. I remember seeing that in the code examples. It
Yeah.
seems kind of technical, though.
It's simpler than it looks. So system is a built-in part of Java that lets you interact with your computer's text-based interface. That console out is like a channel for sending information out of the program. And println tells the program to print a line of text to that console.
So system.out.println is like the program saying, hey, look what I did,
Exactly.
and then showing it to us on the console.
Yeah. It's not just about showing off, though. It's a vital tool for programmers
Mm.
because it lets them see what's happening inside their code while it's running.
So it's like peeking behind the curtain to see the inner workings of the program.
Exactly.
That sounds incredibly useful for like figuring out any problems in the code, any bugs.
You got it. It's like leaving breadcrumbs throughout the code to help programmers see the path the program is taking.
All right, I think I'm starting to see how these different pieces fit together. But before we move on, can we revisit that args example and see how it all connects with system.out.println?
Of course. So remember our word reversing program. Let's say you typed in Java program name hello world. The program would store hello in the first slot of args. We call that args0, and world in the second slot, args1. Then, using system.out.println, the program could print out each word from the args container in reverse order.
Wait, so you're saying this simple concept is what makes those dynamic, interactive apps we use every day possible? That's pretty powerful. It's like unlocking a secret code to understanding how software works.
You're catching on quick.
Yeah.
And, that's just scratching the surface.
This is already so much more interesting than I thought it would be. So we've got our program running, we can give it instructions with args, we can see what it's doing with system.out.println. What else is there?
Well, now that we've covered the basics, we can dive into how all this comes together in real-world applications. Think about those apps on your phone, how they use these concepts.
Okay.
We can explore that.
Yeah, let's do that. We're back, ready to keep exploring this world of Java. Before we got sidetracked, we were talking about how the JVM makes Java adaptable. The main method is a starting point, args, for giving instructions. We even saw how the program shows us what it's doing with that system.out.println thing.
Yeah. It's like we're putting together a puzzle, seeing the bigger picture now.
Exactly. And speaking of pictures, I remember that diagram from earlier. Can we bring that back? See how these pieces all fit together visually?
Sure. Yeah. Visuals always help, right?
Right.
So imagine we have our simple Java program like that word reversing example. First step is writing the code. We save it in a file ending with .java.
Okay, so that Java file is like our starting point, the blueprint. What's next on our visual tour?
Next comes that compilation phase. Remember JavaC, our code translator. It steps in and transforms that .java file into a new file filled with bytecode, ending with .class. So if the Java file is the blueprint, the .class file is like a set of instructions in a simpler language.
Okay, so we've gone from blueprint to like simplified instructions, but those instructions aren't in the computer's language yet, are they?
You got it. This is where the JVM, our star player, comes in. It loads up these bytecode instructions, analyzes them, and then translates them into machine code, the language your specific computer can actually understand and execute.
So the JVM's like the builder, takes those simplified instructions and uses them to construct the final product, adapting to, whatever environment it's building in.
Yeah, I like that analogy. You, as the programmer, don't have to worry about translating your code for different platforms.
Yeah.
The JVM handles all that behind the scenes. That's what makes Java so portable.
Like having a universal construction crew, it can build our program anywhere. Now, can we zoom in on that main method for a second? We talked about it being the front door, but I'm still a bit fuzzy on how that works, like in practice.
Sure. Think of the main method as the starting line of a race. When you run a Java program, the JVM looks for that main method, and it's like, okay, this is where we begin.
So everything inside the main method is what gets executed when the program runs.
Exactly. It's the set of instructions that the program follows. And remember that args parameter we talked about? That's like, it's like giving those runners special instructions before the race starts.
Ah, right. Like, hey, there's an obstacle, gotta jump over it. Or make sure you grab the flag at the halfway point.
Exactly. Args lets us give that program information that can change how it behaves, makes it more dynamic, more interactive.
This is making so much sense. Now, we've talked about system.out.println. Great for seeing the output. But can we use it for more than just printing those messages? Can it help us figure out what's going on inside the code while it's running?
Absolutely. System.out.println is a fantastic tool for debugging. That means finding and fixing errors in our code. Programmers use it to print out values of different parts of the code at various points. It's like leaving notes to track the program's progress, see if anything is going wrong.
So like checking in on those runners at different points in the race, see how they're doing.
Exactly. The more checkpoints you have, the easier it is to figure out, where any problems might be happening.
Okay.
System.out.println, might seem simple, but it's incredibly powerful.
This is all so cool. I'm starting to feel like I could actually write a Java program.
You absolutely could, but for now, let's shift gears a bit. We've covered the building blocks, right? The JVM, main method, args, system.out.println. Now, how about we see how these concepts show up in the real world?
Okay, yeah. We've talked theory, but I'm really curious about how Java is actually used in our everyday lives.
Well, you might be surprised to learn that Java is practically everywhere. From apps on your phone to, websites you browse, Java plays a role in so much of the technology we use every day.
Wow. Okay, so we're back and ready to see how these Java building blocks actually show up in our lives. You mentioned before that Java is practically everywhere. Can you give me some examples?
Well, think about the apps on your phone. Social media, games, online banking, shopping, many of them, they rely on Java. And when you visit a website, that has like dynamic content, like interactive maps or those personalized recommendations you see, there's a good chance Java's working behind the scenes to make that happen.
Wait, so the same Java concepts, we've been talking about, those are what make those complex apps possible. I had no idea Java played such a big role.
Oh yeah, and it goes way beyond those everyday apps.
Yeah.
Java is used in like large-scale systems,
Hmm.
financial software, scientific research, even artificial intelligence.
Hold on. So the same language that makes a word reversing program possible can also power those massive systems. How's that even work?
Java is designed to be scalable, so that means it can handle small projects and incredibly large ones. And because it's so versatile, it's a popular choice for developers across all sorts of industries.
It's mind-blowing that we've just scratched the surface of what Java can do. So we've got these basic concepts, but then they can be combined and built upon to create these really complex programs.
Exactly. Think of those basic concepts as building blocks. Right. With Java, you can take those blocks and build anything you can imagine.
Mm.
Like from a simple house to a towering skyscraper.
This whole deep dive has really opened my eyes to the power of programming in general. I'm
Mhm.
starting to see how understanding these concepts can be valuable even if, I never actually become a programmer. It's like having a decoder ring to understand how the tech around us works.
That's the beauty of learning. It empowers you to see the world in new ways and to understand those forces that shape our lives.
This has been an incredible journey. We've demystified that JVM thing, explored the main method, and even learned how to give a program instructions. And now I'm seeing how those seemingly simple ideas, how they can be used to, well, create such a wide range of really amazing things.
It's been a pleasure exploring with you, and I hope it's made you curious to learn more.
Oh, you definitely have. And for our listeners out there, remember this is just the beginning of, well, your Java journey. Keep exploring, keep experimenting, and who knows, you might create something amazing.
That's right. Possibilities with Java are endless.
Well, that wraps up our deep dive into the world of Java. Hope you've enjoyed the journey as much as we have. Until next time, keep those brains buzzing.